Hi everyone, Aaron here from Tool, and today we're going to speak about the holy grail of CNC routing, feeds and speeds. Feeds and speeds are one of the most important factors of implementing a good CNC strategy, and this can be defined within your CAM software. First of all, what is feed rate? Feed rate is the speed at which the cutter moves across the face of the material. This is commonly measured in distance per minute, for example, millimeters per minute or inches per minute. We're going to refer to this as our movement speed in X and Y. What is spindle speed? Spindle speed is the speed at which the spindle and the tool rotate, which is normally measured in RPM, or revolutions per minute. What numbers should I start with? We've put together a list of recommended feeds and speeds to get you started. These can be found on our knowledge base. We'll post a link in the description below. Remember, these are just a starting point. There are many factors that can have an effect on your feeds and speeds. For example, your material, your cutter, including the type, the material it's made from, and the sharpness, your desired accuracy, your desired surface finish, extraction performance, and your work holding techniques. Just a quick note on feeds and speeds calculators. Traditionally, you would calculate your feeds and speeds for your CNC machine by using chip load and a formula. This strategy does not work on SmartBench, so you'll need to use our quick lookup tables provided. The data is intended for a new SmartBench user. We've tested a range of tools, which are all available on our website. The tables include values for a wide range of materials, including MDF, plastics, hardwoods, softwoods, metals, and composites. What direction should I be cutting in? Feed direction is defined as either climb milling or conventional milling. Each definition simply describes the feed against the material in relation to the rotation of the cutter. This can normally be defined in your CAM toolpath strategy. Conventional milling. When the cutter is doing the deepest part of its cut, it is rotating against the direction of the XY travel and is cutting least efficiently. Note how the width of the chip starts from 0 and increases as the cutter finishes slicing. Climb milling. When the cutter is doing the deepest part of its cut, it is rotating with the direction of the XY travel and is cutting most efficiently. Note how the width of the chip starts at maximum and decreases. Which one should you choose? Climb milling uses less power to move the cutter through the material, so we'd recommend using climb milling on SmartBench where possible. You may have some scenarios where you need to use conventional milling, such as improving accuracy or cutting certain materials. All of the values in our tables are created using climb milling approach. If you need to use conventional milling, then you can do so, but would recommend you reduce your feed rate by around 30% to begin with. How do I know if I need to adjust my feeds and speeds? Before you start, you need to know how and when to adjust your feeds and speeds. This will help you give you the perfect finish. If you're trying something new, like a new cutter or material, you can try testing on a piece of scrap material first. You can then adjust your feeds and speeds throughout the job to get the correct result. Here are a few things to look out for. Always ensure your cutter is in good condition and is sharp and undamaged. You can check the condition of your cutter using a jeweler's loupe. When you're honing your feeds and speeds, ensure you're making chips, not dust. Chips help take the heat away from the material and improve tool life and finished edge quality. Always listen to the sound of your tool as it's cutting. If your cutter is struggling, you will generally hear a higher pitched noise. If you have the Precision Pro model of SmartBench, you may see the spindle overload begin to display on the console, normally to around 20 to 40%. If you witness overload, this could mean that the cutter is struggling. You should try either reducing the feed rate or increasing the spindle speed, or both. Burning is an indication of tool damage or incorrect feeds and speeds. This means that your cutter is rubbing rather than actually cutting chips. Problem solving. You can make adjustments to your feeds and speeds at any time during your job. These can be changed in 5% increments for fine adjustment. If you have any problems related to feeds and speeds and cutting, we've put some extra resources in our knowledge base to help you to get to a solution. We've put a link in the description below. That should be everything you need to know about feeds and speeds. We hope you find it helpful. Thanks for watching.